Thanks for coming back. So far we've only been naming straight chain alkanes, so let's take a look at how you name a branched alkane. Whenever you name a branched alkane or write the formula of a branched alkane, keep these three questions in mind. The correct name of the compound will answer all three of these questions. First question, how many carbons are in the longest continuous chain of the molecule? We call that chain the parent chain. Number two, how many branches are there, and how long are those branches? Number three, where are the branches attached? That is, to which carbon in the parent chain is the branch connected? Remember, if the name you give to the molecule doesn't answer all of these questions, it's not the correct name. On the right here is the structural formula for a branched alkane. The parent chain is the longest continuous chain of carbons, so in this case, it's 6 carbons long. These carbons are numbered in red, 1 through 6, starting at the side closest to the branch. It could have just as easily been numbered 1 through 6 starting up here and snaking around to the right like this. It could not, however, have been numbered 1 through 6 starting at the rightmost carbon, so we couldn't go from this direction. That's because we must number the carbon starting at the side closest to the branch. And this branch, which is sometimes called a side chain or a substituent, this branch is on the left side. Here we're still looking at the same structure. Since the parent chain is 6 carbons long, the name of this molecule will end with hexane. The only side chain on this molecule is just 1 carbon long, right here. So we'll use the prefix meth, which means 1 carbon. But we change the ending from ane to il, YL, to denote that it's a side chain. Since the side chain is on the number 2 carbon of the parent chain, this one here, the name of this molecule is 2-methylhexane. Notice in the name over here that there's no spaces, and there should be no spaces in the name of a hydrocarbon. Also notice that there's a hyphen, not a comma, not a space, between the number 2 and the methyl prefix in the name 2-methylhexane. Now let's take a look at this branched alkane. This one has 5 total carbons, but we can't call it pentane because it isn't one straight chain. The longest continuous chain of carbons has 3 carbons, so the parent chain of this alkane is propane. The 2 side chains are each 1 carbon long, here and here, and they're both located on the number 2 carbon of the parent chain. As a result of there being 2 methyl groups on this molecule, we're going to use the Greek prefix for 2 in addition to methyl in the side chain name. Remember the Greek prefixes mono, di, tri, tetra, penta, and the rest. We won't use the mono prefix if there's only 1 branch of a particular length, but we must use the di prefix here because there's 2 methyl chains, 2 branches that are each 1 carbon long. When we put it all together, the name of this molecule is 2,2-dimethylpropane. Since we don't use any spaces in the name of hydrocarbons, we're going to place a comma between 2 numbers, so we know in this case that it's 2,2 and not 22. And remember to put a hyphen between the numbers and letters as well. What do you think about this molecule? Pause the video here for just a minute and try to figure out the parent chain and the lengths and locations of the side chains. What do you think its name is? You can find this molecule as an example problem, number 18.1, on page 626 in your book. We must first find the parent chain. Is it here? 1, 2, 3, 4, 5, 6, 7, 8. Is it here? 1, 2, 3, 4, 5, 6. How about over here? 1, 2, 3, 4, 5. Nope, in this case, it's that easy one. Straight across, 1, 2, 3, 4, 5, 6, 7, 8. Straight across is an 8-carbon chain. It's an octane chain. But now we have to number the parent chain. Should we number it left to right or number it right to left? Remember, always number the parent chain starting at the end closest to the side chains. If we number this one left to right, the side chains end up being on the 4, the 5, and the 6 carbons. But if we number this one right to left, the side chains end up being on carbons 3, 4, and 5. So that's exactly what we'll do. As far as side chains are concerned, we've got 3. 2 1-carbon groups down here, and 1 2-carbon group up here. Since 1 carbon as a side chain is called methyl, and since there's 2 methyl groups, we're going to use dimethyl in the name of this molecule. Since a 2-carbon side chain is called ethyl, we'll use that name in there as well. When naming organic molecules with different lengths of side chains, always use alphabetical order when arranging them. Since eth comes before meth in the alphabet, this branched alkane must be called 4-ethyl 3,5-dimethyl octane. If it seems like all these rules are confusing, don't worry. Once you get much more practice under your belt, it'll be a piece of cake. Just be sure you don't forget to practice. Here's a formal list of the rules for naming organic compounds as outlined in your book. The IUPAC, International Union for Pure and Applied Chemistry, is the organization responsible for things like the names of the elements on the periodic table, and in this case, they're the ones who make the rules for naming organic compounds. If you don't like the rules, don't complain to your chemistry teacher. Instead, let the IUPAC know of your concerns and your suggestions. They have a website, iupac.org, and I'm sure they'd love to hear from you. Here's the rest of the list of rules from your book. Remember these 2 compounds, butane and 2-methylpropane? Well, now you know why the one on the right is called 2-methylpropane. Because these compounds have the same molecular formula, C4H10, but different structures, and therefore different names, they're known as isomers. Don't confuse the word isomers with that other iso word, isotopes, which are atoms of the same element with different masses. Isomers are compounds with the same molecular formula, but different structural formulas. Just because 2 molecules have the same molecular formula doesn't mean they're anything alike. You see here that butane on the left is a gas used as lighter fuel, but 2-methylpropane is a compound found in shaving gel. Even the boiling points, melting points, and densities of isomers differ. Here are shown 3 isomers of pentane. They all have 5 carbons and 12 hydrogens, but notice how the boiling point decreases as more and more branches are added to the parent chain. That's because the branches get in the way of the intermolecular forces between these molecules. So not as much energy is needed to overcome that attraction to turn the liquid into a gas. Generally, the longer the alkane chain, the higher its boiling point. That's because intermolecular forces increase as molar mass increases. There are no polar bonds in alkanes, so they're just nonpolar molecules. They do not dissolve in water because water is polar, but they will dissolve in nonpolar solvents. In fact, many of the alkanes that are used as nonpolar solvents themselves. Just think of how paint thinner or gasoline can be used to dissolve substances that soap and water can't wash away. As far as chemical properties are concerned, alkanes are not very reactive, at least compared to other hydrocarbons. We'll talk more about those other hydrocarbons next time. Pause the video here until you've located your Naming Branched Alkanes worksheet. There's also one available at mrluzio.com/chem if you've misplaced yours. On the right of the screen, I've got the first 5 structural formulas from that worksheet. Excuse me, that's on the left. On the right of the screen, I've got the names of the first 5 compounds from the back of that worksheet. Practice naming the compounds on the left, then practice drawing condensed structural formulas for the compounds on the right. Remember that every carbon atom in an alkane must have bonds with 4 other atoms. Once you've laid out the carbon backbone, the parent chain, and the side chain, or chains, then go back and add the appropriate number of hydrogens for each carbon so that the total number of bonds for each carbon is 4. For example, on number 11 here, 4-methyl-octane, let's draw the carbon backbone with 8 carbons in the parent chain, because it's octane at the end of the name, and a 1-carbon side chain, methyl, off the 4th carbon of the parent chain. Then let's add 3 hydrogens for the carbon atoms on the ends so that they have 4 bonds, 8 valence electrons, and 2 hydrogens for the carbons in the middle of the chain. Now, on this carbon number 4 in the parent chain, because it's bonded to 3 other atoms, 1 carbon here, 1 carbon here, and 1 carbon here, we only need to add 1 hydrogen atom. Go ahead and pause the video now to practice naming the 5 structures on the left and to draw condensed structures for the 4 remaining molecule names on the right. Then when you unpause, you can check your answer with my key, which will appear in a moment. But make sure you pause now. Did you pause? Good. Here's the key so you can check your work. Circle on your paper or in your notes the ones you missed, and we can talk about them when I see you next in class. Thanks for watching.